this is the stoichiometry homework tutorial for mass-to-mass type problems. So we're going to do a few of these, and these are on pages 5 and 6 in your homework packet. So the first one that I'm going to do, when copper reacts with silver nitrate, copper 2 nitrate and silver are produced. So the first thing we're asked to do is write the balanced equation. It says copper reacts with silver nitrate, so those are my reactants. Okay, copper reacts with silver nitrate. Okay, silver's oxidation number is +1, nitrate's is -1. So you don't need any subscripts here, it's just a 1 and a 1. Hopefully you recognize this as a single replacement reaction. It tells you what the products are, but copper is going to replace silver in this reaction, and you'll get silver and copper 2 nitrate. Okay, so since copper's copper 2, that means it has a +2 oxidation number, and nitrates is -1. So you'll crisscross those, and that will be the formula. Then you need to balance the equation. Well, nitrate, there's 2 nitrates here, 2 NO3s. So you go over here, make that 2 NO3s, which changes the silver to 2. Easy fix. I use a coefficient of 2 to make that silver 2. So there's our balanced equation. Now, from that balanced equation, we're going to do some problems. How many moles of copper are needed to react with 3.50 moles of silver nitrate? There's my given. And how many moles of copper is my unknown? This is just going to be a mole to mole, so we'll do that one first. We start by writing the given, 3.50 moles silver nitrate. And then always disco down the unit. Okay, that's the first thing you do. Even if you don't know anything else, go ahead and disco down that unit. So I put moles of silver nitrate. So since I've discoed down that unit, it says that I'm going from moles of silver nitrate to moles of copper. Well, I can use the mole ratio from this balanced equation to do that. So I put moles of copper in my numerator. I go back to the balanced equation. There's 1 mole of copper nitrate in my balanced equation and 2 moles of silver nitrate in my balanced equation. So moles of silver nitrate cancel, and I'm left with moles of copper. So that's how I know I can start the math. So I multiply what's in my numerator, which is 3.50 times 1. And then in my denominator, there's an understood 1 down here because that's a whole number, and a 2. So 1 times 2 is 2. 3.50 divided by 2, 1.75. And then the unit is that one right there, moles of copper. Alright, if 89.5 grams of silver were produced, how many grams of copper reacted? So this is a gram-to-gram problem. 89.5 grams of silver and grams of copper is what I want to know. Let me adjust that a little bit for you. There we go. So I start by writing what my given is, 89.5 grams of silver. And then I disco down my unit. Grams of silver, my unit. Grams of silver. Okay, in order to go from grams of one thing to grams of another, I have to go through the mole first. So I have to convert this into moles. Well, I know that there's a conversion factor. There's a relationship between grams and moles. 1 mole of any element, such as silver, is its molar mass from the periodic table. So I go back to the molar mass on the periodic table for silver. It's 107.868. Okay, that's the conversion factor that's going to get me to moles of silver. I can convert then to moles of copper, then finally to grams of copper. Okay, a little bit of a roundabout way, but we can do it. So I've got moles of silver, and I disco down the unit. Okay, I want to go from moles of silver to moles of copper because once I go there, I can convert to grams of copper. So I put moles of copper in my numerator. I go back to my balanced equation. There's 1 mole of copper and 2 moles of silver. Moles of silver cancel. I've got moles of copper. Well, now I can convert to grams of copper. I disco down that unit, put moles of copper in the denominator and grams of copper in the numerator. Okay, just like over here, I'm going to use the conversion factor that 1 mole of any element is its molar mass. So you look on your periodic table, 63.546 grams in 1 mole of copper. Moles of copper cancel. And look, I now have grams of copper. Well, since I have grams of copper, I can stop and do my math. So I'll multiply 89.5 times 1 times 1 times 63.546. And I'm going to divide, see, I'll put that number up there, 5687.367. And I'm going to divide it by whatever I find in the denominator. Well, that's 107.868 times 2 times 1. That gives me 215.736. So I'm going to divide the bottom number into the top number. Okay, I'm going to go with that number divided by my denominator. 26.36, oh, lots of numbers. How many sig figs can I have in my final answer? I can have 3. So let's see what we're going to round that to. It's 1, 2, 3 sig figs. So the fourth number, fourth digit, is going to round that 3 up. So my final answer, 26.4 grams of copper. Okay, turn over to the next page. There we go. So given this reaction, when 1.20 moles of ammonia react, the total number of moles of product formed. So I want to know how many moles of product is formed. So what I need to do is I need to go from 1.2 moles of ammonia to nitrogen monoxide, moles of nitrogen monoxide. There we go, moles. And then I'm going to go 1.20 moles of ammonia to moles of water. And then I'm going to add those numbers together, those mole amounts together. So first things first, let's balance this equation. 1 nitrogen, 1 nitrogen, 3 hydrogens, 2 hydrogens. Well, let's see if I try to balance those out by making them both 6s. Let's see if that'll work. Okay, that would make 2 nitrogens. And then I'll check the oxygens. 2 times 1 is 2 oxygens. Ooh, that gives me an odd number of oxygens in my product. So I need to go back and see if I can't fix that. Okay, that's not going to balance out. So let's try again. So what other number do 2 and 3 have in common? Something small. I don't want something really big. What do you think? 12. So let's see if that'll work. I'm going to put a 6 here and make that 6 times 2, 12 hydrogens. And I'm going to put 4 there, giving me 12 hydrogens there. 4 nitrogens, 4 nitrogens. I'm going to count up all the oxygens here in my product. 4 times 1 is 4. 6 times 1 is 6. So 4 and 6 is 10. 10 oxygens in my product. 10 oxygens in my reactant. So not a fun one to balance, but it balanced. So I'm going to go from 1.20 moles of ammonia, and I'm going to calculate the moles of nitrogen monoxide first. So I'll disco down moles of ammonia. Okay, and I'm going to convert to moles of nitrogen monoxide. I'm going to use the balanced equation and get my mole ratio from that balanced equation. There are 4 moles of ammonia and 4 moles of nitrogen monoxide. Okay, moles of ammonia cancel, and I have moles of NO. So let's see, 1.20 times 4 divided by 4, yeah, 1.20. So that makes 1.20 moles of nitrogen monoxide. So now I need to find the moles of water, and then I'm going to add it to this one. So I start with my given, 1.20 moles of ammonia. And then I'm going to disco down my unit, put moles of ammonia down here. And I'm going to convert to moles of water. So I go get my mole ratios. That's 6 moles of water, 4 moles of ammonia. Ammonia cancel, and I'm left with moles of water. going to be 1.2 times 6 divided by 4. 1.8. That means there are 1.80 moles of water formed. So I'm going to add these two guys together. So that plus that, 1.20 plus 1.80, yep, 3 moles. 3.00 moles of total product. So let's go find, yep, there we go. D is the right answer. All right, number 2. This is a little bit of gas stoichiometry. We're using the 1 mole equals 22.4 liters of any gas. How many grams of water are contained in 4.1 liters of steam at STP, assuming the steam is pure water? Okay, this is really not hard. We don't even need a balanced equation for this. I'm simply going from liters of steam. Remember, steam is just water. I'm going from liters of water to grams of water. So there's my given, 4.1 liters of water. And then I'm going to disco down my unit, put liters of water here. And I want to go to grams of water. Can I do that? No, I cannot. There's not a direct link between liters and grams. So, what are you going to do? What do you do first? What do you convert to? Every single one of these Stoich problems, you have to convert to moles. You can do that. Okay, do I know a relationship between moles and liters of water? I sure do. It's right there. 1 mole of water is 22.4 liters. So liters cancel. And then look what I did. I've converted to moles. Do you know a relationship between moles and grams? You do. You learned it. You learned it during the mole unit. 1 mole of water is its molar mass in grams. So what's the molar mass of water? You should have memorized it by now. 18.015 grams. Okay, that's 2 hydrogens plus 1 oxygen. So I'm going to multiply everything in my numerator. 4.1 times 1 times 18.015. And I get that number. Then I'm going to divide by what's in my denominator. What's in my denominator? 22.4. So I'm going to divide that by 22.4. And I will have the grams of water. So how many sig figs can I have in my final answer? I can only have 2. So what do you think my final answer is? There's 2 sig figs. So that third number is the only thing that can affect my rounding. That 9 rounds that 2 up. So my final answer, 3.3 grams of water. Okay, if you need extra help, be sure and ask your teacher. And good luck, guys.